Hello everyone, welcome back to my channel That Teacher Life. In our previous video, we had learned how to identify and define factors and multiples. We were also able to give suitable examples to differentiate between them. In today's lesson, we are going to discuss about the different types of numbers, namely even and odd numbers, prime and composite numbers, twin primes, and co-primes. I hope you all are feeling excited to learn something new today. So without any further ado, let's get started. So children, I'm sure you have all heard about odd and even numbers, right? So can you try to define what are odd numbers? Yes, you're absolutely right. Odd numbers are numbers ending with 1, 3, 5, 7 or 9. That means the digit in ones place of the given number should be 1, 3, 5, 7 or 9. Similarly, even numbers are numbers having 0, 2, 4, 6 or 8 in its ones place. I hope all of you were able to recollect what are odd and even numbers, right? So here I have a small activity for you. As you can see, there are 3 numbers written on the balloons. I want you to help me identify the odd and even numbers from the given set. Are you all ready for it? Alright, let's begin. The first number is 417. Do you think this is an odd or even number? Yes, it is an odd number because it is ending with the digit 7. Let's move ahead to the number 958. What do you think 958 is? Yes, it is an even number as it is ending with the digit 8. So, what about 2073 children? Once again, you all are correct. It is an odd number because it has the digit 3 in its ones place. Great job, children! Now let's move ahead to the next type of numbers, that is prime and composite numbers. But before I feed you with the definition of prime and composite numbers, let me give you few examples. In our previous video, we had discussed about the different pairs of numbers which when multiplied, we obtained 12 as the product. We had 1 into 12 or 12 into 1 is equal to 12, 2 into 6 or 6 into 2 is equal to 12, and 3 into 4 or 4 into 3 is equal to 12. So the factors of 12 are 1, 2, 3, 4, 6 and 12. So totally 12 has 6 factors. Now let's try to find the factors of 11. We know that we can obtain 11 as the product only by multiplying 1 and 11. There are no other pairs of numbers which could be multiplied to obtain 11. So 11 has only 2 factors, 1 and the number itself. Similarly, 2, 3 and 5 have only 2 factors, 1 and the number itself. So each of the numbers which have exactly 2 factors, namely 1 and the number itself, is called as a prime number. 2, 3, 5, 7, 11, 13, etc. are all prime numbers. But numbers like 4, 6, 8, 9, 10, 12, etc. which have more than 2 factors are called as composite numbers. Now you must be wondering, what do we call 1 as? By now, we are all able to figure out that 1 has only 1 factor. So 1 is neither prime nor a composite number. It is called as a universal number. Now children, let's perform a small activity which will help us find all the prime and composite numbers from 1 to 50. This method was originally designed by a Greek mathematician Eratosthenes, and it is known as the sieve of Eratosthenes. Let's see how to perform this activity. We know that 1 is neither prime nor composite, so we separate it by drawing a box around it. Now let's encircle 2 as a prime number and cross out every multiple of 2. So 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48 and 50 are all composite numbers. Next, let us encircle 3 as a prime number and cross out every multiple of 3. However, we need not worry about the numbers which have already been crossed out. So 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45 and 48 are all composite numbers. Next, let us encircle 5 as a prime number and cross out every multiple of 5. So 10, 15, 20, 25, 30, 35, 40, 45 and 50 are all composite numbers. Now, the numbers which are remaining are all the prime numbers from 1 to 50. So 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47 and 49 are all the prime numbers. I hope you all enjoyed this activity. Now children, let's see what are twin primes. Two consecutive odd prime numbers are known as twin primes. By looking at the sieve of Eratosthenes, can you try to figure out the different twin primes from 1 to 50? Do you think we can call 2 and 3 as twin primes? No, absolutely not. But why? We cannot call them as twin primes because 2 is an even prime number. So, can you try to tell me any other pairs of numbers which can be called as twin primes? Yes, you're absolutely right. 3 and 5, 5 and 7, 11 and 13 can be called as twin primes. But what about 13 and 17 children? Do you think we can call them as twin primes? No, we cannot call them as twin primes because they are not consecutive numbers even though they are odd prime numbers. So I hope everyone are now clear with the concept of twin primes. Now let's learn what are co-primes. Two numbers are said to be co-primes if they do not have a common factor other than 1. Let me give you an example. Let us take the numbers 8 and 15. The factors of 8 are 1, 2, 4 and 8. And the factors of 15 are 1, 3, 5 and 15. We can observe that 8 and 15 do not have any other common factor apart from 1. So we can call 8 and 15 as co-prime numbers. I hope you all enjoyed today's video. Kindly like, share and subscribe to my channel for more such content. Hit that bell icon to be notified whenever a new video is uploaded. Thank you.